Next question is this: the gravitational potential energy. Now, in this lecture, we'll discuss about the gravitational potential energy and what is potential energy and how can we calculate the potential energy of anything. All right. So this one is very important. All right. So the case is basically is this: the potential energy is nothing but the work done. As we all know, when the field is conservative in nature, if we perform any amount of work, that work basically stored as energy. We know that. And gravitational field is a conservative field in nature, right? So if this is a conservative field, so if we perform any amount of work inside of this conservative field, this work done, this basically stored as energy, right? This work done will stored as some amount of energy. So in order to calculate that one, in order to calculate the potential energy for the earth's gravitational field, we are taking one situation, and situation is this: the satellite, it was basically it was residing at some distance infinity. Okay, it was at some distance infinity, and we are moving that. Let's say, yeah, it's not working actually. All right, so basically the case is that this satellite that was initially at infinitely a large distance away from the earth, now one external agent which is basically bringing this satellite all the way from infinite to one particular point of the around the earth where there is a gravitational field exists. Okay, the point is that this satellite is being taken or being driven from infinite distance to at some particular point. Let's say this point is P, and which is basically inside of the earth's gravitational field. What do I mean by earth's gravitational field? Earth's gravitational field means inside the radius where we can experience the gravitational attraction force due to earth. All right, so I have drawn one circle, and this circle is basically indicating the range of the gravitational force outside of which the gravitational force we won't be able to experience, although the value of the gravitational force will not be exactly zero, but we won't be able to experience that gravitational force outside of that radius or outside of this radar, and we name this radius or this region is the gravitational field of the earth. All right, so inside of which if one object get inside of which if one object get inside of this gravitational field region, it will experience a attracting force towards the earth. All right, so now this satellite, this was roaming around over the universe, and it was moving here and there, and suddenly one external agent which is basically bringing this object to some point where there is a gravitational field of the earth exists. All right, so now I want to calculate the work done of these external agent. All right, so work done, how can we calculate? We know the very basic formula of the work done. Okay, and the work done is, the formula of the work done is equal to force into displacement. We are taking the small force and small displacement. Now when we have brought this satellite up to a certain point P, now we are moving a little distance, little distance here from P to P dash, and this distance is very small, and this distance, let's say this distance is dr. Okay, this distance is dr, and we are taking from earth to this particular point, this distance is r. All right, so this distance is r and this distance is dr. Now the work done, I want to find the work done, is this dw, that is a small amount of work to displace the satellite from P to P dash, is equal to force into displacement. Now what is force? The force is equal to G capital M small m by r square into dr. Now I have not declared what is the value of the capital M, small m, all that stuff. So this mass is capital M. Okay, now this mass of the satellite is equal to small m, and this distance is r. I already have said that, and here is the small amount of distance which is basically displaced by the external agent, and which is basically pushing from somewhere. It's like I don't know from where he is pushing that object, but yeah, from somewhere it is one external object and one external agency is basically pushing that satellite. All right, so if I want to now calculate the total work, then what we need to do, we need to perform the integral, and dw in the very next step, what we will be doing, that is integral and taking the integral on the both side. Now if you take the integral, the thing is that this is very interesting. We know the very basic idea of the integration. All the terms, they will go outside, right, other than the r square dr, right? Now if I ask you what will be the limit of this, integration, just pause the screen and think and answer this question. What will be the limit for r? Alright, so I believe that you have tried, and the limit of the r will be from infinite to a distance r. From infinite to a distance r, that is the limit. Okay, so if you want to bring this object over the surface of the earth, then you can write down here, that is capital R. Okay, so capital R, you can write it down. So now I want to perform the integration, and the integration is this, basically 1 by r square, that is integration is minus 1 by r gmm of minus 1 by r, and now you need to write down the limits, and if you apply the limit, this will become gmm minus r, and this is the formula for gravitational potential energy. And if we talk about 1 unit mass, if the mass of the satellite is 1, then what will happen in this equation will become very, carefully you can see that gm by r. Now that is the value of the work done, and we can name it the gravitational potential, right, is equal to minus gm by r. Okay, so this is the very basic idea. This is the calculation of the gravitational potential. All right, so see you in the next class.